Okay, hello everyone. Welcome to our today's session, Android Bootcamp Compose Camp Day 2. We will continue our study session on learning Android programming basics. Our today's speaker is Muratbekova. He is an Android developer at Arcana Inc. and he will talk about the Android basics.
Thank you. Hello, everybody. Thank you for inviting me to this event. So let me share my screen and we will start. Okay, you can see, I guess. So today's session will be on Android basics. First, we'll have a short lecture in order to build a foundation for your knowledge and in order or just structure information you may already know. And in the end, we will have a little practice comparing Compose and XML. So starting Android, learning Android might feel like this. And these are things that first comes to my mind when me thinking about any app. Yet, without any division, it's a lot. But if we take a closer look, we will see that these are the features that you will use in any Android app. Shortly, manifest file, it's a place where you declare all your app components, required permissions, hardware and software features. Intents, it's things facilitating the communication between app components. Then Gradle files are used to define your app dependencies, plugins, and API level, and so on. However, these are the things that you actually can use in any Android application, depending on your needs. For example, Firebase, here you can add analytics to your app to see what pages are most commonly used, and Crashlytics to see what pages are crashing, in which pages your app is crashing, and to know exactly where to configure these things. And also a powerful thing in Firebase is remote config, so that you can change your app behavior from remote. Again, you do not have to know how to implement all of this or how it works at the moment while you are just starting Android. It takes your time, but it's better to at least know that they exist, and I highly recommend you to add these titles to your personal roadmap for future exploration. Now I want you to take a closer look to this part, and it is called Android App Components. Android app components are the essential building blocks of an Android app. There are 4 app components: activity, broadcast, receiver, content provider, and service. Activity is highlighted as blue because we'll take a closer look to it later in the lecture. So now let's discover them one by one. First is activity. They contain the UI and handle the user interaction on the screen. It's similarly to web pages. Activity is a page of your app. Activity also has its own lifecycle, and we will cover it later. Second is services. Service is an app component that runs in the background of your app to perform long-running operations. For example, a service might play music in the background while the user is in the different app. For example, music services, Apple Music, Spotify, Deezer. Or you might use service to fetch data over the network without blocking user interaction with an activity. Next is broadcast receiver. It is a component that handle communication between Android OS and application. Other application, your app, you can handle such events as enabling or disabling airplane mode, network connection, and battery states. Also, I've been using broadcast receiver to take location updates from the user. So it's really powerful thing. And finally, content provider. It's a app component that handles data and database management issues. Content provider component supplies data from one application to others. Data may be stored in databases, file system, and somewhere else entirely. Also, an example of content provider is getting your context list to your app. So now let's get a deeper look into Android activity. As I already mentioned, an activity provides a window in which the app draws its UI. So Android activity has its own lifecycle. I really tried to make presentation easier, but this slide is essential, so please make sure that you are paying enough attention for now. Okay, simply, lifecycle Android activity lifecycle is a set of states which the activity goes through while running your application. An activity has essentially four states. First is on the top of this kind of tree, it's running state. It is when activity is in the foreground of the screen, and usually it is an activity that the user is currently interacting with. If the activity has lost its focus, but it's still presented to the user, it's called visible. So it is possible when you use your app in multi-window mode and other activity has like higher priority. In this state, invisible state, such activity is completely alive and it maintains its state. But if the activity is completely hidden by another activity, it's called hidden now. It is third state of activity hidden, and it still retains all state and member data. But if your hardware will need memory for elsewhere, this activity will be killed, destroyed, and this is its fourth state, destroyed. The system can drop your activity from memory by asking it to finish or simply kill the process. But when you will need to show this activity again to the user, it will restore its previous state. So you also, I guess, already have seen such methods like onCreate, onStart, resume, stop, destroy, pause. If you had some practice, these are callbacks that you use to handle transition between life cycle. Okay, it might heard complicated. So on create, it is called when the first activity creation is invoked. Then on start is invoked right before the activity will be visible to the user. On resume is called before the activity will be available to interaction with the user. On pause, called before the other activity will be visible to the user. On stop, called when the current activity is not visible to the user anymore. And on destroy is invoked right before the activity will be killed, destroyed, dropped. So important thing here in this slide to understand is that we do not change the state of activity using these callbacks. Now, it's vice versa. The system invokes each of these callbacks when activity enters a new state. And finally, why do we need them, these callbacks? So we can override these callbacks to add additional behavior to make sure that your app works the way you need. However, you do not have to implement all of these lifecycle methods, but it's important to understand. For example, I guess you already seen that you should write your UI on create a callback of the activity because it is right before your activity is visible to users. So we should place the UI here. And as this workshop is devoted to compose, we will cover composable lifecycle too. Yeah, composable have their own lifecycle too, and it's more simple. Every composable goes through 3 stages of life: entering the composition, recomposition, and leaving the composition. So how it works? When Jetpack Compose first creates your UI, it's entering the composition. However, each of your composable is linked to should be linked to your state, to its state, and when you change the state, Jetpack Compose schedules recomposition and re-executes a composable that might have changed in response of this state. And each change in composable functions, each in composable UIs are working through recomposition only. Okay, I think that's pretty enough for theoretical part. It's a lot to remember. So now let's switch to the practice part. We will create a simple list comparing XML and composables. Okay. Here we have to. Okay, let's go through our files that we covered. For example, manifest file. Here we have 2 activities: compose activity and main activity. As I told you before, we have to declare this our components. Activity is a component, so we declare it here. First, let's do it in simple XML. Where do you think? Okay, you can answer. When do you think we should override? What method we should override to create our UI? I guess you already have seen that it's on create method. So we need to add here additional methods to customize our app's behavior. First, we need to add layout for our activity, and it is created by default when we are creating a new activity. So here we will show a list. So let's just write recycler view. Recycler view is a component which is created to optimize working with lists. And here we now need to add our layout, attach our layout to our activity. How we do this? There is a function set content view, and here we declare which layout will be used to this activity. Okay, now we need to give this layout ID to make sure that we can add our additional behavior to it in our Kotlin files. Like this. Also, recycler view needs to have a layout manager to show which structure will be on this list. Here we'll choose linear layout manager. It means like a horizontal or vertical list. And also we need to configure orientation. And let's have a new function, bind views. Here we will add our layout. First, we need to have to attach very. Let's do this. List. We need to find our view from XML file because we cannot directly refer to it. So we say that it will be recycler view and get its ID. Now we have this recycler view here in our Kotlin file. Let's have additional function, initiate adapter. And now to work with recycler view, we have to create additional file called adapter. Okay, what is adapter? It's file or OP pattern. You can think in those way to bind app-specific data to recycler view. We have not here. Let's remove it. Not in Teams. We create new file called adapter. Here we will pass list. Let's make the strings here. It's the list that we will display, and we need to extend it from recycler view adapter. Also, for our recycler view to understand how to hold the data, we need to create additional class called viewholder. Here we'll pass the view, which will hold our data and extend it from recycler view viewholder. You can see that recycler view requires its viewholder to pass a view, so we get it and pass here. And in our viewholder, we'll create a function called bind. Bind will receive as an argument an element. In our list it's string, so we add an item of string type, and then we will find. Now we need to create an item, additional file, XML file, for each of our items. Here, let's just show it as text. And also to refer to it, we need to add an ID title. Now we need to get this. To refer to this text view, we need to get this ID in adapter. Again, we view find. Okay. Find view by ID from this view and say that it will be text view and show its ID. And now we have the reference for this element. Let's make it wrap content. Wrap content may it will depend on the text that will show here, not on the whole screen. And now we can add this title to our text view. Next, we need to say our adapter that it will receive view holder, our custom view holder. What we see now is that we need to override three functions. First is create view holder. It's a function when we create view holder and in order to use it later. First we create an later. From parent later inflate, and here we declare which view we will use to each element. We created item class, item XML file, and we will declare it here. And return okay, what's later parent. Okay, I forgot from parent context inflate. We are returning. We created inflator, but now we need to. We created a view, and now we need to return a view holder. Let's do it this way. First, we created a layout inflator. Now we create a view in our class and then pass this view into view holder to get this. In the onBind view holder function, we will just get our view holder and invoke its bind function. To this bind function, we need an item from our list, so we just get this list. At this position. Finally, we just need to override this function to make sure that our recycler view will be aware about how many items in this list. Okay, we finished with adapter. Now we need to initiate this adapter and attach it to your recycler view. We create adapter and pass some lists. Okay, let's now create just empty list. A list of string, fill it with log data for 0 to 25 elements. Let's just give it titles using these indexes. And finally, we should pass this list to adapter. And now we will turn this adapter. And attach it to our recycler view. Okay, let's try to... Here, as we discovered before, we need to declare our components, and also there are such things like intent filters, and this filter is showing what is the entry point of our app. We'll try to add it to main activities. We'll start with main activities, so we will add this intent filter to this block. Okay, let's wait for our emulator. Okay, here is our list. As you can see, we had to do such a lot of files to create this list, or even if we need to customize it, we need to color, text size, a lot of things in different files, which may be confusing sometimes, and also it's really a lot of code. So let's just, for now, open second activity, compose activity, and in this mode to, in order for us to compare them. Here again, we need to override on create function. This one, and okay. As you can see, they are extending from different classes, since this class will be composable activity. Let's start. First, we again need to create an item, but we don't have to make a different file, XML file, as we did in this example. Let's show like this. In main activity, we created item. This is our text view with ID. Here we will do the same, but all we need to do is tag as composable and create a function, item view. And here we will pass our title, which is string, and that's it. We need just to create a text here. Let's do it on the row. Text view is called text on compose, and here we pass our title and just add style, which is typography. Let's use H4. Why it's not finding it? Oh, this scope. Okay, let's do without it. Now we need a function where we will contain our activity main. As you remember, we had here our recycler view layout. This time we will do the same, but just simply create a new composable function. We will call it content, or let's just call it list view to simple understanding. And here we will pass our list, the size of our list. We will create a lazy column. Okay. Musical and okay, we will do it later. So now on create, let's attach our new content to this activity. We will use set content function, and here we define our theme. Let's compose camp example theme, our project title. However, in main activity, we declare our theme in Android manifest file here, which is also more complicated just because it's just different files, different places. So now here we create a surface. And here we can add modifiers. Just if we open our main activity, we see that its width is match parent, meaning the whole screen. So we just can do the same for it, but in declarative style. Use modifier and fill max size. And the color also may be declared, but it's not necessary. Theme. Colors. Okay, let's use background color. So we just prepared our surface and we just use our list here with the size of 25. Let's return back to our list view function. Here we use why it's not using why we don't finding lazy column. Here we use items. We pass size over our items. Okay, let's try to do this way. Why don't can find our okay, now it's empty because we changed our starting point in the manifest file. Need to check. We need. It's not finding our styles. Photography and anything. So here. So here we create. Let's. Compose UI. Okay, let's just try to rebuild, because I cannot understand why it's not showing. More features. Window scope. Okay. But maybe composable lazy column. Why it's not finding lazy column? Create items in this size. It should work like this, and we create here an item view with the title of our index. There's something in import. Let me just try to do my compose file. Okay, I'm now restarting my Android Studio because something happened wrong. Let me take a minute. It just happens sometimes. Okay.
Here also some comments come. List is empty. Lazy column uppercase.
Okay. Okay, I restarted. Let's try. Thank you, guys. Yes. Here we items here. Okay, now lazy columns not here. We create. Let's start again. So lazy column. In here we create items using this size and some indexes, and here we invoke our function. Let's now try. And that's we get. What we get is the same list as we got is in our XML files, but let's compare. First of all, we declare this theme in just one word, and in XML file, in XML example, we just need to add this theme in Android manifest file. Then our item is also a separate file. However, in the compose is just one function, simple function, which we can customize here versus also separate XML file was for activity class. However, here we need also just one composable function. So these are the advantages that we get from Jetpack Compose, is that it's really less of code and themes and animations also really easier to implement in Compose. So and you told me I can use a meme, so here. This is old meme for about Recycle View because it really needs to receive a view group, layout manager, view holder adapter, and a lot of features to create a simple list. However, Jetpack Compose provides you an opportunity to create this much faster, easier, and it's for you to just focus on what is important to you. So that's it. Can I stop sharing?
Thank you so much. Do you guys have any questions? Just let us know and write on the comments. And if nobody has questions, we can just end up the event here. Thank you so much, Muragul, for being our speaker for today's event. I think it was really useful for everyone who watched it, and I hope it will be really useful for the ones who will watch after this event. Here are some comments. Great presentation. Thanks, Muragul.
Thank you so much. I hope it will be useful for you.
Yeah, thank you so much for today's event. Follow us, guys, on our social medias, and we will continue our Android lessons on the weekends. Join us to learn more about Android Compass camps. Thank you, Muragul.
Thank you. Okay,